So in this part of the lecture, we'll provide the proof of the sufficiency of the first order condition of the convexity of function. That is, we'll show that if a function f satisfies the first order condition of the convexity, then it is convex function. So let's begin with the proof. So assume that x and y, x and y belong to the domain of the function, and theta belongs to 0, 1. This is a closed set, and that x is not equal to y. And let z be theta times x plus 1 minus theta times y. So we'll assume that we don't know anything about the function, but we just know that the f satisfies over its entire domain that f of y is greater than or equal to f of x plus f dash x times y minus x for all x comma y belonging to the domain of the function. So we also assume that z also belongs to the domain of the function, right? So assuming that f satisfies the first order condition of the convexity, we can write that f of x is greater than or equal to f of z plus f dash z times x minus z. Also, f of y is greater than or equal to f of z plus f dash z times y minus z. So since theta belongs to 0 and 1, so we can multiply the first equation by theta, the first inequality by theta, and second equality by 1 minus theta. And since these both are positive, we can write the resultant inequality as, and we can add these two inequalities to obtain theta times f of x plus 1 minus theta times f of y is greater than or equal to theta times f of z plus 1 minus theta times f of z plus theta times f dash z times x minus z plus 1 minus theta times f dash z into y minus z. So we can write this term as LHS, or the left hand side. So we have LHS is greater than or equal to, we can simplify the right hand side. So this term will cancel out with this theta times f z. So we get f of z plus, we can take the f dash z common out, and we can write inside the brackets theta times x minus z plus 1 minus theta times y minus z. So we can again write LHS is greater than or equal to f of z plus f dash z times theta times x plus 1 minus theta times y minus theta times z minus 1 minus theta times z. So this satisfies that LHS is greater than or equal to f of z plus f dash z times, so this is nothing but z, which we assumed over here, as z equal to theta times x plus 1 is theta times y. So we can write it as z minus theta times z minus z plus theta times z. So this cancels out this term and this cancels out this term. So which means that f of x theta times f of x plus, we just write in the lattice again, 1 minus theta times f of y is greater than or equal to f of z. We can take it to the left hand side and this to the right hand side. So this gives us f of z is less than or equal to theta times f of x plus 1 minus theta times f of y. Now we can write the definition of z, which provides us f of theta x plus 1 minus theta times y is less than or equal to theta times f of x plus 1 minus theta times f of y, which proves that f is convex. Since this is satisfied for all x and y belong to the domain of the function, it proves that f is a convex function. Thus, we started with an assumption that f satisfies only the first order condition of the convexity, and from that assumption we proved that f is convex. So thus, in the previous part we proved that this condition is necessary, and this part proves that the first order condition is also a sufficient condition for any function f to be convex. So that completes. So these two parts complete the proof of the necessity, the necessity and the sufficiency condition of the first order condition of the convexity of function f.